square is that normally we're kind of going back to solving quadratics. If you remember the x squareds, and if you remember the quadratic formula, and if you remember the solving trinomials and stuff, we would see a question, and you don't necessarily have to write this down if you're in class. We would see a question that was something like this. We would factor it +2 + 3. And then because we had equals 0, we were able to take, just one of these at a time. Okay, we were able to say, let's look just at this, x + 2 = 0. Because if this one is equal to 0, we really didn't care about what that other one was. This is all review. You guys hopefully remember this. We get another answer over here, x + 3 = 0, and our two answers would be -2 and -3. And those would come from subtracting the 3, whatever. And so we have this nice property of the 0. Okay? And particularly when you're able to factor it with everything on one side equals 0, it just becomes a piece of cake. Now, unfortunately, we would see other questions that would look like 10x + 3 = 0. And when we would solve these questions, there's no way to factor it. Okay, nothing multiplies to make 3 and adds to make 10, of course, because the only things that multiply to make 3 are 1 and 3. No way you're going to make 10. And so if you remember, our very next step was A, B, C. Let's get 1, 10, and 3. Time to do quadratic formula. X equals, -b plus or minus square root 2a, b squared minus 4ac, blah, 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 right? Whole bunch of stuff. You got to do this whole long process. As soon as we couldn't factor it, our only option was, okay, let's go ahead and do a quadratic formula. Now, the reason is because if we have these two x's, there's no way for us to get these two x's separated in the way that they're separated over here. And that means that we can't take advantage of this 0 rule because we can't split them up like we'd like. Okay, now, if you look down at number 1, this question is like 90% done. So don't expect things to be this easy all week. But hopefully looking at number 1, you've got only one x. And because there's only one x, that means we should be able to solve for this one x. Now, what's a little tricky about this is that it's still technically two x's. If you look at this x squared here, it's basically still x minus 2 times x minus 2. But normally what we've been doing is, we'd write this twice, we'd FOIL it out. But actually, as soon as we get into this state right here, we're able to solve this question. Okay, and we do that by simple algebra 1. It's a little bit of algebra 2. We're going to square root both sides. That's going to get rid of this square. And that's going to leave behind just x minus 2. Over here, you're going to have the square root of 5. And really importantly, whenever you use this strategy of square rooting both sides, you've got to have plus or minus the square root of 5. But then we're pretty much done with the question, right? We're just going to go ahead and add 2 to both sides. And just make sure, this 2 does not add with the 5 because the 5 is inside the square root. So it's not going to become 7. It's just going to become 2 plus or minus square root 5. Now, what this is, it's kind of something that if you're really, really in tune, you can pick up on this. This is the same answer that you would have gotten if you did the quadratic formula. Okay, so I'm going to sprint through this. Definitely don't copy me here, but pay attention and just watch it happen for sure. Okay, if I have x minus 2 squared, that's x minus 2 times x minus 2 equals 5. If I FOIL this, I'm going to get x squared minus 4x plus 4 equals 5. If I subtract the 5 over here, I'm going to get x squared minus 4x minus 1 equals 0. If I do that, there's no way to factor this, so I need to do the quadratic formula. So I need it to be x equals negative b plus or minus the square root of b squared, which is 16, minus 4 times 1 times negative 1. So that would just be positive 4 all over 2a, which is just 2. If I simplify this, that would be the square root of 20. The square root of 20 is 2 square root 5 if I simplify that. And then I'm able to reduce all three of these numbers, and I'm able to get 2 plus or minus the square root of 5 over 1. And I don't need to write that over 1. And so, as you can see, it's the same thing, okay? This is a strategy of avoiding the quadratic formula and kind of trying to skip all that. And if we're able to get it this far, you know, I've written over it now, but the way this looks is x minus 2 squared. If we can get a squared factor, it's a very easy question, okay? And something that's super important, this is one of those things I was saying, if you're not paying attention, you're going to miss this. This number does not have to be 0. That's a huge key here. Every other time we've done factoring, even for the quadratic formula, it's got to be 0. But when we have this squared factor, it does not have to equal 0. So let's look at this one again. Normally, if we want to use a quadratic formula, we'd have to square this, FOIL it, bring the 3 over here, do the quadratic formula. But all we have to do instead is square root both sides. That's going to cancel out with this squared, so we're just going to have x plus 4 over here. Over on this side, we're going to have plus or minus square root negative 3. Okay, this plus or minus is very important, and it's just because we're kind of skipping that quadratic formula, and there's always a plus or minus out front of the square root there too. So it's kind of easy to remember it once you've remembered it once or twice. Now we're just going to subtract the 4, and we're going to get x equals negative 4 plus or minus square root negative 3. And of course, you guys are thinking, well, wait a second, you can't do the square root of a negative. And so you're absolutely right. The real answer would be negative 4 plus or minus I square root 3, okay? Because if you have a negative inside the square root, we bring it out front, we put an I out there instead. So just like quadratic formula, we might get imaginary numbers. That's totally fine. But this step right here is hopefully super, super, super easy. Square root both sides, send the extra number over there. You're pretty much done, okay? So completing the square, you need to understand why we're doing it, okay? Because if we can't factor, it's kind of nice to be able to just square root both sides and add the 3 instead of having to do the quadratic formula. So our objective is, what we want is a squared factor equals anything. But all we need is a squared factor. So here's how a question really looks. Okay. It's not factorable. We could use the quadratic formula, okay? We're basically learning that, you know, first priority, factor, third priority, quadratic formula, but possibly in the middle, we could do complete the square, this new strategy, okay? So we know that quadratic formula will always work, and so we absolutely could do quadratic formula here. But if we can make 2 squared factors, we'll be able to figure this out. Now, what makes this stuff so tricky is that you need to create a squared factor, okay? You need to be kind of outsmarting the question. Right now, it doesn't factor at all. okay? It's not just going to present you with squared factors. You need to make it happen. So here's what we're going to do, okay? The first thing we need to do is we need to analyze what happens when you have squared factors in general, okay? So let me make some room up here. And let's do a little study, okay? If I've got, let's say, x plus 2, and I've got these squared factors. Now, you know, we're writing this like this so far, x plus 2 squared, which will turn into x plus 2, x plus 2. And maybe 2 is not the best. I'm thinking right now, 2 is not the best example. So we're doing this live. Let's go back. If you're writing this, I'm so sorry. Let's do 3. There's a reason why 2 is not as good, I promise, but I wasn't thinking that far ahead. So when we have these two things and we FOIL this, we're going to get x squared, 3x, 9, and we're going to combine these middle two, and we're going to get 6x plus 9. So here's the things that we want to keep in mind. This right here is the same thing as this. Okay, and I know that sounds like, you know, not a whole lot of information. Like, of course, there's two things equal the same thing. But if you want to be good at completing the square, this is the only thing that people really forget. So here's what we need to realize. We need to realize that if we have this number cut in half, right? Because that would be 3 and 3. And those two numbers multiplied together to make that number, that is the pattern that we're finding here, okay? So we need to create this pattern, okay? We need to create whatever this number is, cut it in half, and so you'll do basically 6 divided by 2 equals 3. Take this number and square it and put it right there. So here we go. We're going to outsmart the question here. What we're going to do, first step is we need to get rid of this number. Okay? We want to get rid of that number because it is not the perfect pattern for us. Okay? We're going to make a perfect pattern, so that 3 wants to go away. So what we're going to do is we're going to subtract 3 to the other side and move it over here. But here's a really, really important step. This is one of the reasons it's so hard to teach yourself. I'm leaving a blank space right here because our whole strategy is we're going to need to put in the perfect number right here. Okay, we're going to have to crack the code, solve the pattern, and put a number right there. Okay, now, what number goes here? It has to be specifically only one number, and that would be half of this number, which is -5. And then it would have to be that number squared, which would go up here. And so we're going to have to add 25 on the left side. So now that we've done that, this thing right here is a perfect square, is a repeated factor trinomial, okay? We could factor this now, and don't write this down, but just to prove it to you, you know, that would be 25, that would be 1 times 25, or 5 times 5. How do you make 10? -5 minus 5, that would be x minus 5, x minus 5, that would be x minus 5 squared. Okay, so this whole 25 right here has basically created exactly what we want. So that's really nice. That means that we're going to have over here x minus 5 squared. Okay, this is where I was saying that you need to recognize that this thing right here is the same as this thing, okay? Because what happens a lot of times is students, they understand how the pattern works, they understand how to create the pattern, how to make it happen, and then they just don't like that jump from like, we did all this prep work to make it happen, now it's just time to actually do it. So, good news, we've made this happen. Now, unfortunately, this is a mistake, okay? A lot of people are going to make this mistake. What we've done wrong here is that we cannot just add 25 for free. We can't just put 25 on there and just say this is the same question, because it's not the same question anymore. We've changed it with the 25. What we need to do is put 25 onto both sides. Now it's the same question, okay? Because now we've kept things balanced. And so instead of minus 3 here, actually, we need to have minus 3 plus 25. So it should be 22 right here. And then solving this question is a piece of cake. It takes like 10 seconds. We square root both sides. That's going to be x minus 5 equals plus or minus square root 22. And then we add the 5. 5 plus minus square root 22. There's your two answers. You've avoided doing the quadratic formula. You've gotten your answer really quick. Now, as always, we've just done one question. There's always going to be students who are like, okay, wait a second. Why am I skipping doing the quadratic formula? That's way easier than this. When you first do this question and you're having to kind of solve the pattern and it takes you some time, it does seem like it takes a long time. But what I'm going to do for number 2 is I'm going to speed it up quite a bit. Okay, and when I'm speeding it up, it's not to kind of leave you in the dust, but it's to show you how fast you can solve these questions, okay? So the first thing that I need is I need room right here to add in the perfect number. So I need to move the 7. So I'm going to get x squared plus 2x, leave some room, equals 10, okay? In this perfect spot, I need to have the perfect number. Now, what number goes there is half of this middle number, which is 1, and I need to square that and put it here, which is really easy, just a 1. Now, what I have here is a squared factor trinomial. This is a pattern, and we've made it happen. I also need to make sure to keep things balanced and put a 1 on this side over here. And so I'm going to have 11 on this right side. I'm going to have x squared. And then the number that goes right here is just half of that middle number. So it would be plus 1. You know, over here, it was a minus 5, and so we had minus 5. So that's it. That's completing the square. Solving this is super easy. Square root both sides. X plus 1 equals square root 11. Don't forget the plus or minus. And then we just subtract the 1 and we're done. Negative 1 plus or minus square root 11. Done. Okay, we've saved ourselves from doing the quadratic formula. Again, I was going really fast. All I have to do is make some room, cut it in half, add the squared term there. Now, obviously for this question, 1 squared is 1, so it's a little weird. Oh, let's do number 3 quickly as well, and then I'll probably give you guys a chance. No, let's do number 3 really quickly. So, again, number 1, could I factor this, right? It would still be faster if I could factor this question, okay? But I can't. If this was a 7 here, I could do minus 5 minus 2, but with a 6, no way. So what I need to do is make some room here and get rid of the 10. So I'm going to go ahead and move that 10 to the other side. It's going to become a negative 10. Now I'm going to need to find the perfect number here. And that would be half of this middle number, which is a negative 6. So that's going to be negative 3. And so, Kaylin, what's the perfect number to go in the box here? 9. Yep. We put a 9 there. We have to be fair and put a 9 over there as well. Okay, again, this is something that students are going to forget for sure, is to keep the equation balanced. Now, we're going to have x equals -1. And then, Sienna, what goes in this little spot with the x here? Yeah, -3. So it's really not too bad. Perfect job. Now we're just going to go ahead and finish the question. Square root both sides. We're going to get x minus 3 equals plus or minus negative the square root of -1. The square root of -1 is impossible. It is an I, and so we can make this as simple as possible by looking 3 plus or minus I. And that's that. That is completing the square. So, if you could factor, it would certainly be easier to factor. Certainly. You'd get 2 answers. You know, it wouldn't be a problem at all. If you can't factor, maybe complete the square is easier than quadratic formula. So, let's talk about when would completing the square not be easier than quadratic formula. Let's look at number 5. Can we factor this? No. So we need to move the 2. Okay, so I'm going to go ahead and have x minus 5x equals 2 over here. I need to have the perfect number that goes right here. Now here's where we run into an issue. Okay, this number b, which is -5, when you divide -5 by 2, you get -5 divided by 2. And when you square that, you're going to get 25 over 4. And you're going to have to add that to both sides. And then this is now really gross. Okay? And so, don't do this. Time to do the quadratic formula. Okay? So, when I do completing the square, okay, some people treat completing the square like, listen, I'll learn how to do it, but I'm never going to do it ever again once we take the test, okay? If I ever have to do completing the square, I'd rather just do the quadratic formula because I know the quadratic formula will always work. But I do like completing the square, okay? I will do completing the square if I can't factor, but I have an even middle number, okay? Now, over here with number 6, we're going to see the other problem that you might have when it comes to completing the square. Okay, same idea. Can I factor this? No, I cannot factor this. So I need to move the 7. But my other problem is that I've got this 2 out front. Okay, now having this 2 out front doesn't make as much of a monumental issue as the odd middle number does, but it still gives us a problem, okay? What we want to do with this is hopefully we can do a GCF of the 2. Okay, hopefully we can get rid, and we can. And because the 7's on the other side, we don't have to worry about the 7. We're going to take out the 2, and we're going to have x squared plus, oh, not 20, but 10x equals 7. Now, we're going to need to come up with the perfect number here, and you're going to start getting pretty quick at doing this, okay? Half of 10 is 5. 5 squared, 25. It doesn't take super long to cut a number in half and then square it. So we've got 25 here. Not the reason that this becomes more difficult with this 2 is that we've not added 2. We've actually added, we've not added 25. We've added 2 25s, okay? Because this 25 is multiplied by 2. And so over here, we need to add 50. And that's because this is 2 times 25. So you can see how right away we go from, okay, it's just a little pattern, just pick the right number, not too bad, to, wow, this is a lot to keep track of. This is really kind of stretching me out, wearing me thin a little bit. To finish this, we know this pattern right here is the perfect pattern. So that would be 2 times x plus 5 squared equals 57. And then we would just need to solve it from here. Okay, so first thing I would want to do is divide by 2. So I'm going to get, let's go up here. X plus 5 squared equals 57 divided by 2. Square root both sides. X plus 5 equals plus or minus square root 57 divided by 2. And then subtract the 5. X equals negative 5 plus or minus square root 57 divided by 2. Which again is not a very nice number at all. But we didn't have to do the quadratic formula. I'm not sure if it was worth it. So here's my rules for completing the square. This is the last thing we're going to do for the notes. The main idea of completing the square, okay, I'm not sure where necessarily you want to write this, but is when. Okay, like when should you do completing the square? Because you don't want to do it every time, and you also don't want to force it to happen, okay? Completing the square is like a perfect case scenario. Step number 1, when you can't factor. Because factoring would be easier, for sure. Step number 2, when b, that's that middle number with the x, is even. Okay, because if we're going to chop b in half, we want b to be even. And then step number 3, I'm pretty much only going to be doing quadratic formula when a equals 1. Okay, because I don't really like when I've got something with this 3 out front. I don't really like that. Okay, and so this is kind of when you would want to do it. Now, it is a pretty specific amount of things that you need to happen. And that's why it's kind of like this forgotten thing, okay? Completing the square is something a lot of times you only learn in honors algebra 2, and you just kind of, in regular algebra 2, they're like, just do quadratic formula. Like, don't worry about it. But completing the square, if the star